We feel like it's a positive thing, so positive that we are going to be using it in the 2011 production.
Explaining how carbon technology works is difficult because the chemistry behind it is somewhat complex, but if I could use a simple analogy, scientists frequently call the soil a bank from which plants withdraw oxygen, water, and nutrients. Just as a business's growth might be limited by the amount in its savings account, plant growth can be limited in a similar fashion. Phosphorus is one of the many nutrients essential to plant growth. All soils have a native or a natural supply of phosphorus, but this supply can be inadequate for crop growth and can be depleted by withdrawals made by plants. Research and experience has shown that making phosphorus deposits via fertilizer applications results in increased yields. However, the banked phosphorus in the soil can be robbed and therefore rendered not available for plant growth, possibly resulting in reduced yields. The so-called villains in alkaline soils common in the West are primarily calcium and magnesium. These minerals are found in large concentrations in both soil and water. They rob the plant of phosphorus if it is not protected in some fashion. Thus enters carbon technology, which is a complex mixture of organic acids and other compounds that guard the phosphorus, minimizing it from being robbed away from the soil bank storage vault and keeping it available for withdrawal by plants. So the explanation behind the science of carbon technology is that the organic acids in carbon form bonds with phosphorus. This bonding minimizes the interaction between phosphorus and calcium and magnesium, which keeps the phosphorus more soluble and enhances plant uptake.
The carbon product that we've been using for the last 2 years on our farm is probably one of the better products that we've seen come down.
I believe I'm seeing benefits because of the availability and mobility of the carbon versus the dry fertilizer application.
We've been able to reduce the amount of fertilizer we put on, which is key in this economy. We feel that's a very vital part of the program, and still receive the same kind of production and higher.
The thing that surprised me probably the most was that after we applied 30 units of Carbon P through the water, the petioles reacted within a week or 10 days, and the petioles began to rise. So it was one of the first times we'd ever applied phosphate through the water and got a response from it.
With the carbon, there's something there, because we visually can see that there is a difference.
We need to get the yield out of it within 12 months of when we make our first dollar's investment, and we can do that with Carbon P.
I've done research with carbon for a couple of years now. When I'm looking for a fertilizer additive that actually works and is worth a grower's money, I'm looking for something that's going to enhance ability to supply nutrients to a plant. The thing that I found with carbon that I know for certain is that it enhances solubility of phosphorus and probably some other nutrients as well.
Phosphate has become a big issue probably everywhere, but particularly in my operation, because I rent ground for 1 year and then move off it, and we all know that applying a lot of dry phosphate, you're leaving a lot of it there, a lot of it tied up in soil.
The thing we can say for sure is that when phosphorus is a limiting factor in the soil, that carbon is getting phosphorus into the plant at a much lower volume of fertilizer than we would normally see. We're seeing increases in yield, and I think that's part of the key, is putting on a lower rate of fertilizer in order to maximize efficiency.
So to be able to cut down the rates that you're using and cut back on some of the cost and know that you're still getting the phosphate you need is really big for me.
We've worked with corn and wheat and potato and beans and several other crops that and been able to show that we are getting more phosphorus into the plant. Carbon seems to be making phosphorus available in the soil for a longer period of time. It's safe to say at this point that, well, yeah, we can cut phosphorus rates by 30% and still get as good or better yield with less phosphorus fertilizer.